Okay, it's time for round 2 of real-world quadratics. Same information here. 3 ways to solve, although we'll usually do factoring or quadratic formula. Especially for real-world examples, typically you'll have whole number answers, so factoring is usually a good way to solve those. But if the numbers are too big and you don't feel like it, quadratic formula always works. Square root, sometimes you'll see those, but for the examples we're doing, it's usually factoring in quadratic formula. So, okay. Some of these examples we have done, one of them anyway, but there's another type I want to look at. So it's a little different than the one we did earlier in the week, but it is very similar. So, first example. The dimensions of a picture inside a frame of uniform width are 8 by 10 inches. If the whole area, picture and frame, is 224 inches squared, what is the width of the frame? Now, we've done a similar question to this in a different unit with a walkway around a garden, and you'll see that in example B, it's worded the same way. But we solved it using geometry. But we can set up a quadratic equation to solve this problem, and maybe you think it's a little faster. So I think always good idea to draw a picture if you're not sure, exactly what's happening here. So if we think about, that's terrible. So if we think about a picture, and it's not much better, oh well, inside a frame, okay, the picture is 8 by 10. So let's say 8 by 10 here. And the frame is some uniform width, we don't know. So let's call that X. And it's the same width, X, around the entire frame. So if the whole area, the entire thing, is 224 inches squared, what's the width of the frame? So we're solving for X. And so we have to come up with an expression that represents length times width of the entire object, right? Well, we've done this before. The vertical distance here is 8 plus the 2 x's on either side, so 2x plus 8. And the width is similar, but it's 10. So 10 here plus the x here and the x over here. So this is 2x plus 10. So the equation that we want to write is just the area formula for a rectangle. So 2x plus 8 times 2x plus 10 equals the area 224. I'm going to go ahead and shrink this because we're done with it and it's in the way. But if you want to see it, just go to the beginning of the video. So now we have to do some math. So 2x times 2x, 4x squared, plus 20x, plus 16x, plus 80 equals 224. And then we're going to have to combine here, subtract here. So we get 4x squared plus 36x, and then 80 minus 224, let's just make sure we get it right, is negative 144. And that equals 0. Now, you might notice we can divide everything by 4 just to make it a little easier. And since it's equal to 0 and we're taking just a constant out, we don't have to keep the 4. So x squared plus 9x. And then if we divide 144 by 4, that's negative 36. So x squared plus 9x minus 36 equals 0. That's a little easier. So if we think of factoring, we want to get to negative 36, two numbers that multiply to negative 36 and add to 9, well, that's 12 and negative 3. And so you can factor by grouping here. Or remember the shortcut where if your leading coefficient is 1, and the two numbers we get are 12 and negative 3, our two factors are going to be x plus 12 and x minus 3. But let's just go ahead and make sure that that trick actually works. So we get x plus 12 and then minus 3 here, x plus 12, and yep. So our two factors are x minus 3 and x plus 12. And so the question asked us, what is the width of the frame? Well, if our two solutions here are 3 from this one, 3 minus 3 is 0, and negative 12 from this one, only one of those answers can be correct because our width is a positive number and negative 12 is not positive, so it can't be the width of a picture frame. So our answer here is 3 inches. Right, x equals 3 inches. So 3 is the width of our picture frame, which gives us an entire area of 224 here. Okay, so we've done that problem before just using, I think maybe we factored it or we used geometry, something, but you can use the quadratic method here. Okay, next example. A garden measuring 12 feet by 16 feet has a walkway around it. So this is the same problem, right? We have a garden that's 12 by 16. It has some walkway around it. What's the width of the walkway? Well, that's x. The tire area is 285, so we know that this is going to be the same setup as example A. So we've got 12, I'll put it the 2x first, 2x plus 12 times 2x plus 16 equals 285. So these two problems, A and B, are actually the same problem. It's just one is in terms of a picture frame, one is in terms of a garden. But in both cases, you have a rectangle surrounded by a bigger rectangle. And we're basically finding the width of the difference here. So let's multiply. We get 4x squared plus 32x plus 24x plus 12 times 16 is a big number, 192, equals 285. Got to do some simplifying here. So 4x squared will also subtract 285. So we got 4x squared plus 56x minus 93 equals 0. Unfortunately, this time we can't divide. We can't simplify because 4 doesn't go into 93, 2 doesn't go into 93. So we can't make this any easier on us. We're going to have to factor this pretty messy equation, right? 93 times 4. So two numbers that multiply to negative 372 and add to 56. I don't really want to do that because I think it'll take too long. So let's just use the quadratic formula, which with bigger numbers, it's a little harder to do just space-wise, but it'll be a little faster. So x equals the opposite of b plus and minus the square root of b squared. So 56 squared plus the calculator does everything for us. So 3136 minus 4 times a times c. A is 4, c is negative 93, all over 2a, so 2 times a, which is 8. So it's all in there. It's big numbers, kind of a mess, but you know, the calculator does it, so we don't have to. So let's figure out the radical. We've got 3136, negative 4 times negative 93 is positive 1488, so plus 1488, which is going to give us 4624. Okay, so x equals negative 56 plus and minus the square root of 4624 all over 8. Let's see what that is. Hopefully it's a real number and we get 68. Great. I'm kind of running out of space here. I think maybe I'll just erase this line. Hopefully you're okay with that. You can go back and check and see what it was if you want. All right, so x equals negative 56 plus and minus 68 all over 8. So negative 68, or negative 56, sorry, plus 68 is 12 over 8. 12 over 8. And our other answer, negative 56 minus 68 over 8 equals negative 15 and a half. The negative answer doesn't work, right? Because we can't have a negative width. So our answer, 12 over 8, and because we're getting an actual width, it is more useful to get a decimal here. 1.5. So x equals 1.5 or 1.5 feet. So like I said in the last video, when you get two answers, when you have a real world problem, usually you're looking for a real world answer, which in most cases is a positive answer. Technically, there's a negative number that will satisfy the same problem, but that doesn't work in the real world because we're looking for a physical width. Okay, so the length of a rectangular plot of land is 20 feet longer than its width, and the area of the land is 2,400 feet squared. Find the dimensions of the rectangular field. So this is just like a problem from the last video. We have a rectangle, and we're giving the dimensions in terms of the width. So if we have the width here, and the length is 20 feet longer than the width, well, that's just W plus 20. And the area is 2,400, so we've got W times W plus 20, so length times width, equals 2,400. And we can make that into our standard form, W squared plus 20W. We're going to subtract 2,400 from both sides. That's not a W. Minus 2,400 equals 0. All right, so we need two numbers that multiply to 2,400 and add to 20. 6 times 4 is 24, so 60 times 40 is 2,400. So we're looking for W squared plus 60W minus 40W, right? That's our factoring method. Minus 2,400 equals 0. 60 and 40 are our two numbers. So now you can factor by grouping. So W times W plus 60 minus 40 times W plus 60. So our factored form of this equation is W minus 40 times W plus 60 equals 0. So our two solutions for x, or W rather, are 40 and negative 60. Well, negative 60 can't be a width. So our width is 40, which means our length is 20 plus 40. So our length is positive 60. So that one worked out sort of with the negative 60, but as we saw in the previous problem, it won't always work out that way. So there's your solution there. The dimensions of the field are 40 by 60. So there you have it. The two new problems we did here, the picture frame or the walkway. You've got two of those, I believe. Yep, 1 and 2 are that type of problem. 2 is worded a little differently. You're going to have to figure out the area and realize, it's half, so it's worded slightly different, but it is the same type of problem, so you'll have to kind of figure that out. 3 is just like the third example in the notes here, so do your best, give it a shot. As always, email if you have questions.